Swayam Prabha. Digital India. Educated India.
So, today is the 7th session of Ergonomics for Beginners Industrial Design Perspective. Now, it is under module number 2, that is discipline approach, ergonomics and human factors, and there are total 5 sessions, and this is the last session in this module. It is class 7. Is physiology, work physiology and stress relevances. Now, whatever we discussed in earlier classes, now let have a summary of this. Like ergonomics uses knowledge of human body and varied aspects of mind towards creating situations for our own benefit. Whether function we do, whatever function we do with effort, its effect reflects on physiology. While of using any product or any other utility item in different manner, so finally the workload we are feeling or the stress we are feeling, it is visible through our body expressions, and that is true, and also in physiological parameters. If we measure, then we can find that what is the workload on that, whether it is good or bad. Now, physiological stress sometimes wrong design induced. If the design is not proper, that to use that man has to take lot of troubles, then it creates a stress, and that reflects in physiology. Now, the training and experience guides skill performance. The frequency we use or we do certain activities, our skillful movement or skill increases. As for example, to do certain job where when muscle force is required, the young person he can do the same job using whole body muscles, but when a skilled person does the same job, then he uses specific muscles is necessary to perform that job, that is the skill. So, we can say that a training and experience guides skill performance. Now, why designers also need to know the physiological parameters? Because knowledge of physiological parameters assist in evaluating design and work method, whether it is really effective, it is good for our health. Now, current session, now today we are going to discuss, in this current session we shall discuss muscular function and some physiological stress indicating parameters through skill to perform task work posture and physiological load, physiological considerations, muscle and its contraction, schematic diagram of muscle details, and role of food and source of energy. These areas consist today's discussion. Now, if we see this figure, this is a hill. On this hill, after taking out some soil from this hill, the hill becomes barren. To cover this exposed surface, lump of grass is being fixed with a small bamboo piece, that is small, and a small bamboo stick here. The small bamboo stick on a barren hill surface to cover it to save erosion and for beautification also. Now, work tool is a bamboo piece with a narrow holding area to hold it and a beating head a little thicker side. The task is nailing in nature. Now, in this what can be said that the person has to perform a balancing task while performing the job. Now, he has to stand in a slanting surface. So, to maintain this body position posture, a certain group of muscles are already involved, and over that when he has to perform the skillful task of nailing the bamboo pieces with grass lumps, then it is also another skillful movement. So, to do this job, he has to divert his total activities, one in maintaining balance of his whole body and to perform the task. So, now the whole outcome depends on how he can make balance between these two requirements. Now, if we see from the close point of close, he is just placing the lump of grass on this hilltop and bamboo pieces to be used to nail, and the bamboo hammer are carried in hand. So, the both hands are used to. So, this is a complex task. Now, while making this complex task, how we are manipulating our muscles, it makes a great impact, means the skill of using specific muscle groups. Now, if we see the loom work, in this loom work, now this person is sitting on a bench and working. He is pedaling also here and also working. In this case, can be said that this much portion remains static, whereas his arm and leg portion are dynamic. In this case, here also it can be said that the same thing, the lady has to maintain a specific static posture at the buttock area, whereas the top portion and the leg below leg portion, these two portions are dynamic. So, this task is a combination of static and dynamic both. So, the coordinated body movement, both static and dynamic, involving muscle power to operate. So, how skillfully we can use our muscles, the performance outcome is related with that. Now, work posture and physiological load. Now, this work posture and physiological load, when we perform some task, the task demands a specific postural adaptation. Now, for that, if we stand and bend forward is a normal practice, but if the task requires side bendings and backward bending, it is not quite normal. So, we have to maintain the control locations in such a way that person do not need to bend in sideways, back or at the front, that is beyond his safe limit, and accordingly the design has to be done. Like in this case, the lady is pulling a trolley. Now, if the trolley design is not proper, then the total load what is coming, it affects the back. So, it can be said that appropriate design and correct method of operation reduces physiological load and thus result in performance increment. So, we must be aware of the posture. Now, if we see the ergonomic risk factors, now if we explain from a fire triangle principle that heat, fuel and oxygen, if any one or all three together, if we reduces its intensity, then the total fire intensity also decreases. In the same way, to do certain task, the posture of man, the force he is applying and the frequency of that force application and the posture adaptation, these three together, this triangle, this is called the triangle of ergonomic risk factors. If any one is out, it would minimize the risk. Now, how we can understand or measure this risk? Among many methods, the physiological stress measurement is mostly accepted. Now, while operating and using the design, user's physiological stress must remain within tolerance limit to ensure safe use and comfort, covering various endurance capabilities. Now, what are the parameters? Among various indicating parameters, cardiovascular measures, energy requirement in terms of oxygen consumption, that is the difference of oxygen inhaled air and exhaled air. Body temperature, when our body is in active or working, then our temperature increases. So, how much temperature is increasing, that gives that load feeling. Muscle electrical activities, that is electromyograph, etc. are normally used as parameters to understand the physiological stress while using a design and performing a task. Now, some facts, the physiological considerations. Now, energy, power and heat. Now, limit the energy expenditure in a task. Now, how we can limit this and what are the background? So, if we measure this energy, so power and heat, then it can give us a judgment. As for example, it can be said that a normal body at resting condition, it spends around 80 watt. Without fatigue feeling, till 250 watt, including resting value of 80 watt, as for example, writing, typing, ironing, assembling light materials, operating machinery, a gentle walk or leisurely cycle riding, it is there. Means this task requires around 250 watt. Till that we do not feel much fatigue. So, now what is 1 watt? 1 watt is equivalent to 0.06 kilojoule per minute, and that is 0.0143 kilocalorie per minute. Now, rest is necessary after heavy tasks. Why? Why this rest and pause system is there? Because when we perform some heavy task, then our energy reserves are being utilized, and to repay that debt, we need some time, so that during that time an additional expenditure should not be there. So, it is said that rest is necessary after heavy tasks. Now, examples of activities demanding in excess of 250 watt, that is, additional measures are necessary to avoid exhaustion in the long run, that is, breaks, alternation of lighter activities, etc., are necessary to introduce. Now, just for some understanding, that activities, some activities and energy expenditure is given below. Walking while carrying a normal load around 30 kg, so 4 kilometer per hour, if with that speed if we walk, then the energy expenditure is around 370 watt. Frequent lifting, that is 1 kg of load one time per second for 1 hour, it is around 600 watt. Running in a speed of 10 kilometer per hour, but 10 kilometer in an hour, 670 or 670 watt. Cycling, that is 20 kilometer per hour, this is 670 watt. Climbing stairs, this 30-degree stair angle, 1 kilometer per hour, that is 960 watt. So, these are been measured. So, if it requires more energy, suppose we have changed the angle of the staircase or the speed of climbing, then if we measure his energy requirement at that moment or energy expenditure at that moment, so it will be more than this value. Then we can say that whether, or if we have less degree or less or slow speed slowly, then it may be considered around this walking normally. So, there this will be less. So, by that way we can say that whether for a specific group of people or a specific person, the angle what would be the ideal. Along with this measurement, the subjective judgment is also necessary to understand whether he is feeling comfort. Now, people always say that if there is any problem we anticipate, then prevent. Now, how we can prevent and what are the mechanism can be used? Like it is normally said that warm up and stretch before activities that are repetitive, static or prolonged. Take frequent breaks from any sustained posture every 20 to 30 minutes. So, if you have to adopt a specific posture for more than 20 to 30 minutes, then it is better to break for some time, take rest or change posture and then come again. Respect pain, positions or stop painful activity. Now, if we overlook, the pain is an indicator of internal problems. Now, if we do not give attention to this pain, then it may lead to a grievous problem. Recognize early signs of inflammatory process and treat early. Now, how to treat early? Here comes the design activities. With proper design aid, we can treat this. Now, people say that with addition to the design, try to modify tasks. Now, how to modify tasks? People say, it is said that alternate activities frequently, rotate heavy and or repetitive tasks with or a lighter less repetitive ones you use it. If the situation becomes worse, reassess task setup and look for alternative models. Avoid repetitive or prolonged grip activities. Avoid bending to sides. Take frequent breaks to stretch and rest hands. Normally, it is seen that while we are doing certain work where our arms are not really involved, still the stress on shoulder and arm is there. So, it is better to give whole body rest and at the same time, if it is not possible to give whole body rest, at least give a arm support to have a rest. Now, if we see all the movements and etcetera are basically for muscles. Now, if we see our body, on the bony structure, the muscles are there, all muscles are distributed all over the body. Different shapes and types of muscles are there. Mostly it is said that a muscle has two ends as tendons. These tendons are joined in the both bone pieces. That bone is joined with a hinge. So, now if both the places the tendons are joined, then what happens with the muscle contraction through the tendon, the bone distant parts come closer. This is the flexion movement, and at the same time the opposite muscle, the extension muscle, it has to expand, otherwise the movement is not possible. And at the same time, when extension is there, means when the extension muscle is contracted, the flexor muscle has to be relaxed. So, this is the basic matter. Now, there are muscles in long muscles for normal movement, as well as there are some oblique muscles to give the arm rotations or any body parts rotation. So, with combination of these muscles, the total skillful movement in our body is possible. Now, we will see some facts about this muscle construction and some muscle activities. Now, muscle and its contraction. Now, if we see this slide, this slide mentions that movement in human body parts are due to widely distributed systems of muscles, which together make up approximately 40% of the total body weight and their coordinated actions. Our skillful movement is due to the coordination or coordinated action of different muscles. Each muscle consists of a large number of muscle fibers. The details in a figure we will see now, which may vary between 5 millimeter to 140 millimeter long according to the muscle size. The diameter of a muscle fiber is about 0.1 millimeter. A muscle contains around 100,000 to 1 million such fibers. The fibers of long muscles are sometimes bound together in bundles. At the end of the muscle, all fibers are combined into a tough and nearly non-elastic tendon. These tendons are firmly attached to the bones. With the muscle contraction, as the bony parts are attached with tendons, it pulls the distant parts of bones, so that a coordinated movement is possible. Each muscle fiber contracts with a certain force, and the strength of the whole muscle is the sum of these muscle fiber force. The maximal strength of a human muscle lies between 0.3 to 0.4 Newton per millimeter square of the cross section of a muscle. Thus, a muscle of 100 millimeter square cross section can develop 30 to 40 Newton force. Hence, a person's inherent muscle strength depends in the first instance on the cross section of his or her muscles. Now, male and female variations in muscle power. Women have in general narrower muscles and they exert on an average about 2/3 the force of men. Now, why we need to know this matter? If we have to design a product where muscle force is necessary to operate, then whether it would be used by man or a woman, depending on that force requirement mechanism has to be developed. If it has to be used by both, then obviously the female force has to be considered, so that a big range of population can use that. So, for this type of decisions, these knowledge are necessary to understand by design communities. Now, give equal training, women and men can become equally strong per cross section. There are strong women and weak men also there. A muscle produces its greatest active strength at a beginning of its construction. When muscle starts contracting at the beginning, it exerts maximum force and then slowly it reduces or it maintains then that. When it is still near the flexion length, as the muscle shortens, its ability to produce force declines. So, for that, now if we have to design a product where a gear or a lever we have to pull, then what is the distance of pulling where we can exert maximum force, that we need to understand. While developing any concept where both the group is expected to use the system, male and female, these aspects needs to be considered. Now, how nerve moves? Who asks nerve to contract or relax? The nerves send signals to muscle to contract, and sensory stimuli to be judged, and accordingly conscious effort would be done. Means how the input comes to us through all the senses, internal ear, external ear, eye, then skin, then skin for tactile senses and taste, smell, etc. All the input transfers to electrical signal, it goes to brain, it gets judgment, and then the flow comes to, information comes to the muscles, and then accordingly muscles get contracted, means our motor activity starts. So, the pathway from this input entry and judgment done and it come to the muscles for motor activity, the pathway to convey the message is nerve. Now, in this case we can say that while operating, how much pressure and force is required here, it depends on the force pressure we are applying on it, and that gives a input to the brain judges, and whatever is being written here, that another input goes through eyes, and in a combined judgment the input comes to the specific muscles, how much pressure to be exerted for a skillful movement. Now, we will see the muscle structure. Most of the body muscles are called striated muscles. Why it is called, that we will discuss now. Now, with this is a schematic diagram of muscle. This is the total muscle, this end portion a non-elastic element, it is tendon, and this is the muscle group, and muscle has many fibers. Now, the striated muscle A is made up of muscle fibers B, means with many muscle fibers, a combination of this is the main muscle, which appears striated in a light microscope. Light microscope, this appears as a striated, means marks. The small branching structure at the surface of the fiber are the end plates of a motor nerves. Now, on this the motor, the nerve ends comes, which signals the fiber to contract. Each single muscle fiber, see, is made up with myofibrils, small fiber, beside which lie cells, nuclei and mitochondria. In a single myofibril, the striations are seen. It is specific pattern wise. Now, what are the patterns? Now, here we can say that this a small area, if we see here, then this mark is called Z line. So, between these two Z lines there are some strands. It is that a single unit of this pattern consists of a Z line, this one, then an I band, a specific band position is there, it is called I band, then A band and again I band and Z band. So, this is a unit. Within this A band there is some thick colored, black color and some are the white, little less thickness color. So, then an A band which is interacted by a Z zone, this is the Z zone area. Then the next I band comes and Z band. Now, what are these things? In this, these bands are formed with two types of protein fibers, actin and myosin. This joinery of this fiber is the form Z band. Now, actin and myosin, if we see from in between these two Z band, in this Z band these muscle fibers are attached like this way, like this, and within this some fibers are placed like this. So, with this actin and myosin fibers, from this band there are some small protrusions are there, and these protrusions here in this fiber some grooves are there. So, when this muscle is activated, then this muscle, this protruded tip pulls this through these grooves to inner side. So, what happens? This muscle it becomes squeezed, because what happens? If it is like this, if it pulled down like this way, pulled inside, so then total muscle fiber, this band decreases. So, as a resultant force, the total muscle gets contracted. So, this muscle fiber, this repeating band pattern is due to the overlapping of thick and thin filaments in this, and these filaments act like this. During a period of muscle contraction, a number of actively contracting muscle fibers determine how strength is developed. Muscle fibers are attached with nerves, and the amount of muscle strength produced is determined by the number of nerve impulses, and that is followed by specific motor nerve cells in the brain that have been excited. Thus, the input of stimuli intensity matters to ignite brain cells. The speed of a muscle contraction depends upon how quickly force is developed during a given interval of time, so that rapidly of a movement is governed by the number of actively contracting muscle fibers. Now, some more facts can be discussed here, that the static muscular effort can be said that when muscular contraction is kept constant, the muscular contraction is kept constant and slow for a long time, muscle fiber are brought into active contraction following a sequence of succession, and they may alternate the contraction while the tired one can go for relaxation. Thus, some individual muscle fibers get some resting pause, and this permits some recovery from fatigue to take place, but the muscle effort must be within low load. Perhaps we have seen when we sit for a long time, we cannot maintain the same posture, there is a sway movement like this, or we try to change our body position. So, why it happens? This is the matter. Means to maintain this position, a specific muscle group is involved. When those muscle strands are tired, then neighboring muscles they take over the load, and then earlier one gets rest. So, for that what happens, our body movement is there. So, it is very difficult to sit for a longer time in a position without any movement. Now, this knowledge how we can use in a design. If the seat plate is very hard, then the whole body load will be concentrated to some points, and then a very specific selective group of muscle will be involved to maintain that posture, and quickly they will tire. So, what happens? There will be some sway movement frequently, but if it is a soft padding is there, then what happens? The total load will be distributed to certain position where the muscles responsible to maintain that posture, there will number will be more. So, their total load will be less. So, that position they can maintain little longer time. These facts should be considered while conceiving a task design to be performed with muscular effort. Now, the role of food. How we get the energy. Now, if we see this slide, here it is specifically mentioned that these low energy phosphate compounds are continuously converted back to this high energy state of the muscle, so that the reserve of energy available to muscle remain undiminished. This conversion requires energy gained from digestive foodstuffs. Means in our body, whatever we eat, it gets digested, then it goes to blood, and from blood it goes to the cells inside the cell, and then inside the cell it breaks down to pyruvic acid, and accordingly, and in that process in presence of oxygen, it makes ATP, adenosine triphosphate, and these are the energy reserve. So, when the muscle contraction takes place, this ATP triggers this actin myosin movement, and it breaks down to adenosine diphosphate. So, this total process is the aerobic glycolysis. Now, if the oxygen supply is deficient, then the process is anaerobic glycolysis. Now, thus diet plays its desired role. If the main diet is not proper, then this energy formation will also be less, then the total activity of the muscle will also decrease. The regeneration of high energy phosphate compounds with ATP itself consumes energy, means it after consuming energy it stores and then it, which is obtained from glucose and components of fat and protein. These nutritive substances glucose, fat and protein are therefore the indirect energy sources for the continuous replenishment of energy reserves in the form of adenosine triphosphate or ATP or other energy rich phosphate compounds. The glucose passes out of the bloodstream into the cells, where it is converted by various stages into pyruvic acid. Further breakdown can take two directions depending on whether oxygen is available, aerobic glycolysis, or the oxygen supply is deficient, then it is anaerobic glycolysis. So, what happens? When we do some heavy load work, our energy reserve goes down, or to so that what we require more oxygen supply. So, we start panting, and this also becomes an indicating factor to recognize the workload. Now, the source of energy. Now, muscle reserves chemical energy, that is adenosine triphosphate and that matter. During contraction, it transforms into mechanical energy, means stored chemical energy while doing some activity, means this energy is transformed to mechanical energy. The release of energy by chemical reactions acts on the protein molecules of the actin and myosin filaments of the muscle, causing them to change position, so bring about the contraction. So, each that from Z band to Z band, that unit it squeezes, another squeezes, another squeezes, like that. So, the total muscle gets contracted. The source of energy most widely used by living organism is adenosine triphosphate, which when broken down into adenosine diphosphate, the process releases a considerable amount of energy. This energy creates a mechanical movement. Now, the today's summary. The today's, if we summarize the total matter what we have discussed, and we are going to point out specifically that the human body and movement basics we are discussing, and its application and biomechanics and etc. it will be the next classes we will discuss. Now, on the basis of bony structure, there are muscles distributed, and as they are joined two bones with a joint in between, while the muscle contract, there is a bend in the bone joint, and this is the total movement. If all these contractions are coordinated, then a skillful body movement is possible. The most important characteristics of a muscle is its ability to contract, that is shortening of its length to about half of its normal length. This is the most important characteristic of a muscle. means it can contract till its half size, half of the length. When due to muscle contraction two bone ends come close in flexion, muscles are flexor muscles, we call them, and when it expands, it is extension movement. Muscles are extensor muscles, like this. When we flex something, the flexor muscle, it contracts, at the same time the opposite muscle, the extensor muscle, it gets relaxed or extended. When we make the extension movement, then the extension muscle, it contracts, flexor muscle, it relaxes. So, for any bone joint movement, both the antagonistic muscle groups are active. If the flexion has to take place, flexion muscles contract and extensor muscle relaxes. For extension movement, the reverse action takes place, and with the coordinated movement, all these things. And now, how much control we can exercise here, that gives us a skillful movement, and all this is being judged by our brain power. Our brain judges that. So, now skillful movements of us are due to coordinated movements of both these antagonistic muscle groups exist in our body. If any work demanding posture demands a specific load on any muscle group, ultimately fatigue and related other physiological problems are there. Now, whatever we discussed today, these are the general muscle matter, how we move, coordinated movement possible, what type of coordinated movement is not desired. If we have to make a design or develop a work process, then what type of movement requirements we should consider, like this. In next sessions, we will start the module 3. In this module 3, we will discuss the human physical body or human physical dimension concerns, mostly the human physical body, that is the length, the whole body structure, movement, bionics, etc., and development of the body and the structure and its growth relevances, and the male female variations, and how to measure those things, human body dimension, that is anthropometry, etc., we will discuss in next module. And after these basics, we will see its design relevances. So, till then, thank you very much. So, today's session is end here.